Okay, in this question, we're told that in the titration of 100 milliliters of 0.400 molar HONH2 with 0.200 molar HBr, how many milliliters of HBr are required to reach the equivalence point? All right, well, it may not seem like it when you read this question, but really this is a Chem 1 review problem. It's essentially a solution stoichiometry problem. Because what we have here is we have a titration of this weak base, okay, and we are titrating it with this strong acid. So, and another important thing to remember is what we mean by the equivalence point. So at the equivalence point, that's when the moles of the weak base in the sample is going to be equal to the moles of strong acid added with titrant. Okay, so the moles of the base equals the moles of the acid at the equivalence point. So that's really what gives it away. That's a stoichiometry problem, because what's going on is we have this weak base, okay, and that is going to react with the strong acid. And because that is a strong acid, this is going to be a complete one-directional reaction. So every one of these will react with one of these. It's not an equilibrium reversible process. And that's a one-to-one thing. Okay? And of course the products are going to be the H plus is going to come off of the acid and get added to the weak base. So it's going to be HONH3 plus aqueous. And then the bromide ion aqueous is the other product. But that's not so important. The most important part is that mole-to-mole ratio right there. It's 1-to-1. So I can use stoichiometry to solve for how much of the titrant I'm going to add based on the moles of weak base that I start with. Well, I know that I start with 100 milliliters of this weak base. Okay? And one thing I want to do is just go ahead and convert that milliliters into liters. There's 1,000 milliliters in 1 liter. And that's because the next factor that I'm going to use is the conversion factor of its molarity, the 0.4, and that has units of liters in it. Molarity, if you remember, means moles per liter. So I have 0.400 moles of this weak base in every 1 liter of it. So right now, my units of milliliters cancel and liters cancel, so right now I have units of moles of the weak base. Well, again, my mole ratio is 1-to-1, so I will need 1 mole of the strong acid for every 1 mole of the weak base that I want to neutralize. Okay, so now my moles of weak base cancel, and I have moles of the strong acid. Well, I also know the molarity of my strong acid. It's 0.2. Okay, now I'm going to do the reciprocal of that so that moles cancel, but it says that I have 0.200 moles of the strong acid in every 1 liter, but I'm going to go ahead and say that that's 1,000 milliliters, right? Because the question asks for how many milliliters, so I'll just go ahead and express the volume in milliliters. Okay, so moles of the strong acid over moles of strong acid cancel. I'm left with units of milliliters of this strong acid that I need to add. And if you do the math there, plug all that into your calculator, you get 200 milliliters of the hydrobromic acid solution would be needed to neutralize this solution of weak base in order to get to the equivalence point.